And I'll get my hands on the clicker and we'll be ready to go. So as Joe said, I'm going to give a talk about some of the surveillance techniques that we're using in our program to eradicate hawkweeds from New South Wales. And Jess did ask me to talk about dogs, but I thought I'd throw a few things in from our high-tech side as well. So I'm going to talk about some other integrated surveillance mechanisms that we're using to try and eradicate hawkweed. So why hawkweed? So Nancy pointed out, you know, eradication and prevention, that's where we get our best bang for our buck. And hawkweeds are really nasty weeds. We can ask our friends across the ditch in New Zealand about that. They've got about 6 million hectares of New Zealand infested with, and that's just the South Island, with hawkweeds. And that has caused such agricultural damage that people have abandoned farms because it is a very damaging species. It's very invasive in other parts of the world as well. It not only threatens agricultural productivity, but it threatens biodiversity. And we had some modeling done, and we think in Australia that just in Southeast Australia alone, about 27 million hectares of prime agricultural land and biodiversity could be at risk from hawkweeds to the nature of about 68 million per annum just to the grazing industry. So it's a huge risk, this species. It's nasty, as I said. It's a daisy. It's wind dispersed. So you can see the seed head there in the picture. And it's got vegetative spread. It's also allelopathic. You can see down in the bottom corner, that's mouse ear hawkweed, and you can see everything in the middle of that little invasion is just bare earth. So it's really, it excludes other vegetation. It's non-palatable. It's just nasty. But the good news is, in Australia, it's at the very early stage of invasion. So we have the most effective mechanism here could be eradication, to actually eradicate these species from Australia. Where are they? So at the moment, they're confined to the Alps, the Australian Alps. I'm going to talk about the New South Wales hawkweed eradication program. We work very closely with the Victorians. This is a cross-jurisdictional eradication program, and we work very closely with the Victorian government. They have similarly small infestations in the Alpine region in Victoria. You can see there in the map the two infestations we have in New South Wales. The big orange box up the top is where orange hawkweed is. That's in the northern part of Kosciuszko National Park in the Jagungal Wilderness area, so some really remote terrain. But importantly, the red circle there shows the total amount of orange hawkweed on the ground we have ever found is 8.46 hectares. So there's not much of it out there. It's very rare in the environment. And in fact, the year before, we had only 0.1 hectare of it controlled. So. But we haven't found it all yet. And then with mouse ear hawkweed, this is a very new invasion. We found this in 2014. It's right up on the main range. If anybody's been walking in Kosciuszko, it's right around the corner from Mount Kosciuszko, right on the main range walking track. So we think that this seed was probably introduced on a hiker's boot from New Zealand. But again, very important, there's only 0.83 meters square. There's just, a couple hundred meters of it in Australia, which is all dead now. So that's where it is. What are we doing? So in New South Wales, we have the operational objective overall for eradication. The key objectives under that are delimit the infestation. So what that means is draw a box around the whole infestation. Where is it in the landscape? So we know where every single plant is. In order to do that, we have to find every single plant. We also have to halt reproduction, make sure it doesn't set seed, and then exhaust the seed bank, and then we can look at eradication. So how are we doing that? We've got a whole range of integrated surveillance strategies, and it goes from, and again, it's not high-tech and low-tech, I guess it's high-tech and old school, and core components of that include volunteers and staff on the ground, surveying in emu parades and that sort of thing. We also fly them in to remote areas and drop them off and they survey. We also have weed eradication detection dogs, which I will get to soon, and a whole aerial attack as well that we're doing research on trying to find this from the sky. And I'll briefly touch first on the eyes in the sky, and then I'll talk about the wet noses. But yeah, the key point is to eradicate. We have to find every last plant. So our eyes in the sky. We've been working for about the past 3 or 4 years to perfect the use of drones. As I mentioned, you can see up in that top corner photo there, it's a really rugged, remote wilderness area where we're looking in for a lot of these, for hawkweed. And we need help. We can't possibly do that much human surveillance with the current resources that we have. So we've been looking into drone technology. We were able to create an algorithm that can read imagery from drone-collected imagery, to find the orange flower. So you can see that bright orange flower of hawkweed up there. It's about 2 centimeters across, and the algorithm can see the orange color in the imagery that's detected, that's collected by the drone. So the important part of that is the orange flower only appears in December and January. Right? So we have a limited window where we can search for this. But we have perfected the drone technology now to be able to fly the drones. We can get about 55 hectares a day, 60 hectares a day done with a drone. That's an order of magnitude higher than our surveillance on the ground. And it gives us a huge increase in survey efficiency. And we're also able to fly the drones in via helicopter and then fly the drones in the remote areas because you have to have drones within line of sight. So this is quite a high-tech operation. Just to give you an example, that image down in the corner there, the orangey color, sort of squiggly area is about 8 years of human surveillance. So you can see all those orange colors where that, and those are the hawkweed infestations. Sorry, the dots are the hawkweed infestations. I'm sorry, that's probably hard to see for some of you. And then the square, very neat, colorful areas are the drone surveillance. So you can see within a couple of years, we already have as much drone surveillance as we've had over 10 years of on-ground walking. So it takes a lot of work, takes a lot of energy. We have to develop wind models, and we have to develop where to search models and all those things that go behind that, but it's working really well. As I said, the limitation on that is that we only have an algorithm that finds the orange flower. So we're saying, well, hang on, we need more than that because we've got mouse ear hawkweed, which has a yellow flower that looks like every other dandelion that's out there. So how do we do that? So what we're doing now is we're also looking at using spectral imagery, working with the partners at Macquarie University and Charles Sturt University to look at the use of hyperspectral or multispectral imagery. So that's plant reflectance in non-visible wavelengths. So importantly, the word there, plant. So we're looking for the whole plant, the leaves, the mats of hawkweed on the ground. We can see a lot more with this technology, but we haven't perfected it yet. But what we think, we hope, we've done some surveys already, is that with the multispectral or potentially hyperspectral, so the difference between that is multispectral is a limited number of bands, where hyperspectral is lots and lots of bands. So it's big data, data-rich, lots of money, huge processing power needed. We hope we don't have to go there, but if we do, we will. But at this point, we're looking at multispectral and doing some feasibility analyses on that, and it looks good. The good part about this is you can collect this from a drone, you can collect it from an airplane, and there's satellite imagery that gets flown all the time that we can potentially find these plants from. And a bonus on top of that is that we'll be able to create a spectral library. So this image here is some of the early work we've done, and what that is all those colors represent different plants and their spectral images. And so when you collect it, you don't just collect images of the weed that you're targeting, you collect images of all the co-occurring species as well, native or weeds, because you have to differentiate them from each other. And the key point there is that orange line is an orange hawkweed plant, and you can see that in some of those bands, those are the bands across the bottom, the wavelengths, in some of those bands it's different from the other plants that are out there. So we think we have a really good chance of being able to determine orange hawkweed just using spectral imagery on just the plants. So big, exciting stuff for us in the how do we search the whole area space. Getting closer to the ground. This is a cute part of the presentation with our little wet-nosed dogs. I'll introduce Sally and Connor. These are the Hawkweed detection dogs, and they are the first weed detection dogs that we know of in Australia. And everybody asks the question, why dogs? Well, we know that dogs have proven detection ability. We use dogs all the time in biosecurity issues and in a whole range of issues, and it's a really good ability to detect things. And we thought that when we have human surveillance on the ground, obviously there are gaps. People miss things. Things are under rocks, things are under tussock grasses, etc. We thought that we could get the dogs to improve the confidence of human surveyors and find those plants that are hidden in vegetation in particular. And in particular, they are finding the plants before they flower. As I said, we need to stop reproduction to enable eradication. So finding those plants before they flower is really important. We started a project. We all thought, oh, can we really do this? And so we wrote a project, and we got an innovative grant to allow us to train 2 dogs. We got a professional trainer, and he said, gee, I don't know if we can do this, but he persisted, and was able to do it. So we got 2 spaniels, 2 new dogs. So new means they've never previously been trained on anything else. They were young dogs. We trained them only on plants. They've never been trained on animals or any other kind of detection, and which is important because we did trial it with a dog who had been trained on pest animal detection. And she was great. She found the hawkweed, but every time there was a hare or a rabbit or a cat, she'd go, "Whoa, hang on," because cats take precedence over hawkweed, right? So these dogs have only been trained on plants. And so when are we using dogs? How are we using them? So there's only certain times where the dogs are useful to be deployed. Really importantly, you want to use the dogs when the target is really low in the environment. You have to have a very low density of your target. So hawkweed's perfect because we have very little of it in the environment. And we use them in particular where we get into difficult to search areas where the people can't really see things, but the dogs can sniff them out. So you can see some of the photographs there. Those are all on the, in Kosciuszko, on the Connor down here on the main range, and the ones on the right there in Kosciuszko. In these rocky areas, there's often plants hidden under rocks. There's tussock grasses. There's places like this. The far photo there with the red circle, there's actually a hawkweed plant in that red circle. None of us could see it, but the dog found it. And we had 2 teams walk by that site. So it's invaluable when the dog finds a find like that. We also use them for retiring sites. So extirpation, which just basically means local eradication. So when we think every hawkweed plant is gone from that site, we run people through, but then we run the dogs through just to give us that double check to say, okay, we might not be able to check that site next year, so we don't have to worry about it. And they're also good for rapid searches of vast areas. Are they working? Well, yes, they are. And they're working in lots of different ways, but most importantly, they have found new sites for us. They have detected unknown plants. They've confirmed site freedom, so we're saying there's no hawkweed in that site anymore. The dogs have confirmed that. And we only get to deploy them about 12 weeks each season, but they've done a lot of work in those 12 weeks. And they've also not given us false positives, so they're not saying that it's hawkweed when it isn't hawkweed. So they've got expert noses. We're also working with folks at Cindy Hauser and the group at University of Melbourne, and they're doing putting some scientific rigor around this, and they're doing some experiments where we're taking the dogs out and comparing how dogs and people search for hawkweed. And you can see that little graph up the top. This is one of their assessments that they did, and you can see that in the dark blue is everybody found the hawkweed. The red is only the people found the hawkweed, and the green is only the dogs found the hawkweed. And that little other sliver is nobody found it. So there's a lot of lessons in that little pie chart. But one of the key lessons is that there's a niche for everything. There's a niche for the dogs, there's a niche for the people, and we're working on operationalizing that now. This is just a little graphic of how important the dogs are. So what you're looking at there is a valley, and that's a topo map of a valley where mouse ear hawkweed is on the top of Kosciuszko. The yellow dots are hawkweed, where hawkweed plants were. And the top red circle, that gray, is a dogged track. So the dogs have collars on, GPS collars on. They're tracked constantly. Those are a whole bunch of dog tracks laid on top of each other. And down in the corner, you can see the green up and down blue in the blue circle. Those are human surveillance tracks. So humans follow very, very particular grids. Dogs don't. But dogs don't have pre-assumptions. And that little black box in the middle is down in a wet part of the valley where we as humans assumed that hawkweed wouldn't grow because it's wet. We thought, oh, it's not going to grow in standing water. Well, the dog didn't have that assumption. The dog found a new site and changed the whole way we searched that valley. So just that one particular example is, for us, is an amazing thing. And the other point is that they work really hard. So for about every kilometer the humans do, the dogs can do about up to 15. So that sort of leads into some of these factors that affect what we do and how the dogs can work and how well they work. Obviously, there's a lot of factors around the dogs and what conditions they can work in. The weather is obviously a big factor: wind, heat, snow, all the terrain. And we have very dense areas of infestations and dense vegetation. So we have to be very careful to make sure that we monitor the dog's stamina. We have to have very well-trained and specific handlers. That's not an uncostly proposition, but the handler also has to have dog handling skills as well as botanical skills, because they need to tell whether that's hawkweed that the dog is indicating on. so they can reward the dog. And I forgot to mention, the dogs only work for tennis balls. They're real cheap that way. That's all they care about. They don't care about the Hawkweed or anything else. They just want that tennis ball. So the handler has to be very careful to keep the dog focused and rested, work the dog into the wind so the dog can pick up the Hawkweed. We also have to use aversion training with the dog so that they don't go near snakes or poison baits and things like that. So it's quite a complicated project. There are lots of costs, but there are a lot of benefits to the project as well. And as I mentioned, their effectiveness has been the main benefit. But just an overall idea of costs, it's cost us about $150K to get to this point now. That's in addition to all the staff and in-kind costs that have gone into the project. So it's not a cheap thing, but it's had a lot of benefits, and I'll talk about that in a second. And in terms of the challenges, what we're trying to do now is optimize the use of the dogs. Where do they best fit into the eradication program? And then get them some other work as well. So speaking of some of the other work, we have looked at training Connor on another weed, and that's alligator weed. Some of you might know that. It's a weed of national significance. There are lots of places, including Victoria, where our alligator weed is slated for eradication, and parts of New South Wales as well. So we thought we'll give it a try and see how many weeds the dogs can actually detect. And the folks in New Zealand have had dogs that can do up to 5 or 6 weeds, so we know that that can be done. A good lesson that we learned out of this was that it's really quick to train the dogs on new weeds. It's less than 6 weeks. We had this dog trained on another weed, and he was out. You can see him standing in the water there. It's an aquatic weed, alligator weed. So he's poor dog. He's standing in the water, indicating on alligator weed in the water. And it was just a tiny little fragment that's being held in someone's hand down there of dead alligator weed. And so their detection ability is fantastic. So they've been successful there. They've been successful obviously in Hawkweed, and we want to look at some additional priority weeds as time goes on. We are keeping Sally as the Hawkweed champion, and that's a little bit of an anecdotal thing too, to see if there's any difference between, as you train the dog on more weeds, does it affect their ability to find other ones, and so far, no. Some of the massive unexpected benefits to this has been the insane amount of media that we've gotten and amount of coverage. I've worked in weeds for 25 years, and this is the first time I've ever had media calling me and saying, can we do a story on your weeds? I mean, your dogs, So it's been fantastic, and the really good part about that for us is it's sharing that eradication message. And so, and of course the media love the dogs, the ministers love the dogs, we get a lot of political support, and they're just champions of the program, so it's fantastic. And I'm probably running low on time, so I'm just going to try and get through these last ones quickly. Future potential, there's a lot of potential for using these dogs for other things. We were talking about Phytophthora earlier. They're using dogs for Phytophthora now in New Zealand, which is fantastic because you can't see that at all. So, this is an amazing thing that we can potentially do here. They're using them for threatened species in the US, and we want to do that here as well. So we want to keep them on plants and pathogens, but hopefully in the future we can do that. And then just in summary, I just want to go back to what is absolutely not low-tech at all, but is the actual core of our program, and that is people. And while the dogs and the drones are fantastic at complementing and adding value to the program, the core of the Hawkweed program and most eradication programs is people and our volunteer program. So it's been wonderful, and to see the volunteers get excited about the dogs and drones as well is very good. So I'll just leave it there, and thank you very much.